One of the keys to writing good consumer tests is actually knowing what not to test. Restraint is really, really important because it is very easy to write Pact tests that are brittle and overly strict and burdensome. And those are all the things we're trying to escape by using Pact. We don't want to be back in the integration test hell. Writing good Pact tests can be the difference between a really good Pact implementation and one which makes people wish they were just back in the old end-to-end test world. It is really critical. And in fact, there was a Pact user who wrote a blog post recently about how he'd started a new consumer and provider with Pact and how their previous implementation had not been very good. And these are all the things that he'd learned that was going to make this one so much easier. It can be done badly and has been done badly. So what does a good Pact test look like? What qualities are we aiming for? Well, there should be sufficient number and strictness of assertions to make sure that the response from the provider is not going to break the consumer. However, we also want to keep the scope of the consumer code under test as small as it can be. We want to keep the expectations on the response as loose as they can be. And we want to focus on the messages, on the request and the response, not on the implementation. So there's this kind of tension. We're aiming for just the right balance of coverage. We don't want to be so strict that nobody can make any change without breaking a test. And we don't want to be so loose that the provider can make changes that break the consumer. So, scope, the first of our points, scope. When Pact was first written, it was on the very first project that it was written for, it was used to test all the different layers of that application. It was a consumer, and it tested from the UI. These were UI-driven tests, and the tests covered the presentation layer, the business logic, the data access, and this turned out to be a really bad idea because there was a whole lot of duplication in there because people started testing variations that were just about testing UI features rather than backend features. So we'd end up with extra interactions in the Pact that didn't actually really need to be there. What you want to do when you're writing your Pact tests is to just focus on the code within your consumer that is responsible for making those HTTP requests. So probably inside your consumer, you're going to have something that I would call an API client. And it's the code that converts backwards and forwards between the business domain classes of your consumer and HTTP. And it might abstract the fact that you're using HTTP in some way. So it might return change a 404 response into a null. It might raise an exception when there's a 500 error. A 401 might, or a 400 might raise a validation error. So there's going to be something in your code that converts the consumer concepts to HTTP concepts, and that's really what you want to be testing. So the data access layer, the API client. So for maintainability reasons, we don't want to include the UI in there and all the business logic. I've seen this happen, and the teams that have done this have really regretted it. So on the consumer side, you still at some stage want to have some tests that test all the way from the top of the consumer to the bottom of the consumer. And you can still use Pact to help support those tests, but don't use Pact to mock out tests. Don't use your end-to-end test to generate the Pact. But what you can do is use the Pact that was generated by the unit tests along with the Pact stub server. There's a couple of implementations of the Pact stub server, and this takes an already generated Pact and creates a stub out of it. You can also use a completely separate HTTP mock library and either use that generated Pact to prime the stub, or you can use shared fixtures between the code that does the stub and the code that generates your Pact. There's a fairly sophisticated stub called, I think it's Mountebank. And I'd be really interested in seeing if we could use a Pact to set up the mocks on that, because Pact is really not the right tool for long ongoing tests. You typically tend to just mock 1 or 2 requests on the mock server at once. And if you find yourself mocking more than that, you're probably testing too much. And you're going to find your error responses hard to read. If you're doing that, you're potentially veering into trying to do functional tests, which is not a good idea with Pact, and we'll cover a little bit more of that in a second. Okay. So that's it for scope. Did that scope, I'm just going to check in and give you guys an opportunity to ask a question at the end of each little section. That was the scope section. Did that scope section make sense? Keep in mind, it's going to be entirely different on the provider side. Yes? No? Yep. Okay, cool. I'll keep going. All right. So matches. Okay, so remember I was saying the qualities of a good Pact test are getting the scope right and making the assertions as loose as you possibly can. So when Pact was first written, all the matching was done exactly. Or actually, no, that's not a lie. You could do an exact match or you could do a regular expression match. And Pact had been used for a few months, and the amount of JSON that was going into these packs was getting bigger and bigger as the services were developed more and more. And there was this one particular service that had quite a big JSON document, and I actually got so sick of the test failing, the Pact test failing, because the exact matching was failing. And it was really bugging me, like that the ID was the fact that the ID was wrong was making it fail, and then there was a street name that the capitalization was not quite right. I'm like, this is really, really annoying. So I actually put this little hack in the code. And it was the class, I didn't know what to call it at that stage. I was like, I'm going to call this class something like. And that ended up being actually the most useful feature of the Pact matching suite, which is the ability to say, I don't actually care what the exact value of this field is. It should just be this type. And it just needs to match this example. So if you're in, so I keep clicking, should not click. Depending on your Pact implementation, there'll be something that is called like or something like. In JavaScript, obviously it's going to be a function, and the function is called like. So you can say, I want to match any string. You just say like and then give it an example string. Now that example is what is going to come back in the response from the mock object. So it's always nice to have to give it an example rather than just say I want a string, because then you don't know, then the tool would have to generate a random string for you, and that would make your test a little bit difficult. So it's all of the JSON types, string, number, Boolean. The matching I'm talking about here, it's worth mentioning, is for the Pact specification version 2. So there are 3 specification versions that are kind of generally used. Actually, that's not true. The very first one never made it out of realestate.com. Version 2 is the one that most of the implementations support. Version 3 is supported by the JVM implementation and Rust, and that's because it was written while I was on maternity leave. So I still haven't actually managed to get version 3 into the Ruby implementation due to 4 years of having children. And ever since well, actually for quite a while, we've been talking about moving all of the implementations that wrap the Ruby standalone onto this shared Rust lib. And it's just taken us longer than we hoped and expected. So I was never going to implement version 3 in Ruby because I was like, oh, we're all going to move to this Rust implementation. And 4 years later, we still haven't moved to the Rust implementation. But there is recent movement on it, and I hope it is coming. So these matches here that we're talking about are version 2 spec, which is what Pact.js implements. Version 3 has some extra matches where you can say what type of number, so whether it's a decimal or an integer, and it has a few some more sophisticated matching rules. I'll pop a link to it into this presentation, and if you're using one of those languages, then I'll let you have a read of the docs because we don't quite have time to cover all the different variations today. Okay, so that will match an object, a hash, and it needs to have the exact keys, but each of the values will be matched using type-based matching.
Okay.
So, yep. So that will flow down. So this address object inherits the like from the parent. So once you've turned on the like, it flows all the way down. And that's 90% of the time you would wrap a like around the entire response body. There's very few reasons where you'd want to do an exact match. There's a few good reasons why you might want to do a regular expression match, but like most of the time, you just want a like. You don't really care about the values that in the fixtures on the provider. You just care that the shape of the document looks the way that you think it should.
Okay.
Now it can extend that like-based matching for arrays. So you can say each like and give it a single object, and you would get an array of that type of object. So each like and give it a string, expect an array of strings. Same for integers and booleans. You can also do it for objects. So you say each like, and then you can give it an object, and each element in that array needs to have those keys, but it doesn't matter what values it has. Now you can also put a minimum or maximum onto that array as well. By default, it's minimum 1. You cannot have minimum 0. And the reason you can't is this concept which comes up a few times where we don't want to be in the situation where all our tests have passed because there wasn't any data present. So for example, if we had each like and we gave this this shape of this little object here, and we said minimum 0, every one of our provided tests could pass with an empty array. And then we might be thinking, oh, okay, all our tests are passed, we can deploy to production. We deploy to production and bam, it blows up because finally our consumer code meets a real example of this array and it doesn't look like what it thought it looked like. So that's why you have to have one example in there. People often say, "Oh, but what if the test data? Like, I don't know if my test data is going to have this or not." Basically, if you can't really control the test data down to how many items are in the array, Pact might not be the best tool to use. There's some fundamental assumptions that you need to meet before Pact is a good choice for your situation. And one of them is you have to be able to control the provider data. like every element of it, every object of it. And if you can't, then use another tool. That's my advice. All right, some things to remember. Responses can have extra keys without failing the verification, but requests can't. So Pact follows Postel's law, which is basically we're going to be really strict with the data we send out, but we're going to be as flexible as we can be with the data that we accept. So this means that matching rules for our request, if we made an each like when we were matching on our request, if we had an extra field in there, that would mean that we were sending out more data than our test said we should be. So that test would fail on the consumer side. On the provider side, the provider can stick whatever they like in there and not fail the test. And one of the things you can't do in Pact is actually assert the absence of a field. The idea behind that is that the provider should be able to do whatever they like and meet the requirements of any other consumer without it affecting this consumer. So we don't want to be in the world of the old, I don't know if you guys ever did much soap work. I only did the very smallest amount, but I can see a laugh there. You know, when one consumer needed a new field, everybody had to update their WSDL. Yeah, we don't be in that situation where the changes required for one consumer break our tests. So basically, you can only assert what is there. You can't assert what isn't. So you can be as strict as you like on your own requests because they're your own tests. You can make them as loose or as strict. You're not going to be making life hard for anybody else by making the expectations on the request strict. Okay, so there's a link to the V3 matches, and I'll send these slides around later. Okay, so this is a really hard concept for people to get their heads around. The difference between a functional test and a contract test. So contract tests should only be focusing on the messages, that is the request and the response, or if we're talking about a message-based application, then, you know, the message. We only want to write our tests around that message flow. We aren't trying with Pact to test that the provider has been implemented correctly. So this is the big trap that newbie Pact developers and testers fall into, is that they're trying to use a contract test to make sure that the provider does the right thing with the request. And that particular concern doesn't belong in a Pact contract test. It belongs in a functional test for the provider. So as an example, if we send a post to the /widgets endpoint, then we would expect a request. Well, sorry, we send a post to widgets endpoints with a request body containing the widget properties. So we want to, in the Pact test, assert that we got the right HTTP response, that the location header of the new widget was there, and that the response body contained the widget properties. A functional test might test all of those things, but as well as that, it would check for side effects. So you'd probably say at the end of it, and did this request increase the number of widgets stored in the repository by 1 or something like that. Pop quiz. Could you hard code a provider implementation that passes the contract tests but actually doesn't do the right thing? I'll give you 30 seconds to think about that. Tick tock, tick tock, tick tock, tick tock. The answer is yes. You could write a completely bollocks provider implementation that passed the contract tests but doesn't do anything right. What stops that happening is the functional test in the provider's own code base. Is that making sense? Yep. So the moral of this little rant here is that contract tests aren't designed to operate on their own. The test pyramid is a oversimplified view of how we write tests, but the main point of it is that the more code that our test covers, the fewer of that type of test we should have. So we want to have a lot of isolated unit tests that give us really fast feedback, and we want to have much fewer end-to-end tests that cover like all the systems at once. And in between, we're going to have various scopes of testing. Now, our contract tests kind of sit between, they're kind of really borderline between our isolated tests and our integrated tests, because on the consumer side, they're more of a unit test, but on the provider side, they're kind of, their scope can be a bit bigger. They're a bit more like a component test. We'll cover that more in a second. So if consumer teams are getting all upset about the fact that their contract test isn't making sure the provider is doing the right thing, they need to relax, because that's not the job. It's not the job of the consumer to be a test harness for the provider. The provider team is responsible for writing their own tests. Okay, so is there a bit of duplication between the functional and the contract tests? Yeah, a little bit. But in the Venn diagram, there's a little bit of overlap in the middle, but not entirely. So the contract test only covers the attributes of the request and response that a particular consumer cares about. And by design, it excludes the things that the consumer does not care about. There might be fields that they don't care about. There might be headers they don't care about. There might be particular endpoints that they don't even call. A functional test would cover all the functionality that's available to all the consumers. So here's an example of how we might do it wrong. Imagine we're writing a test for creating a user with a username with 21 characters, knowing that our username limit was 20 characters. So you might say when we do a post to /users with a username that is too long, then we expect a 400 bad request, and we expect this particular error with this exact string in the error response. Now, firstly, this is bad because it focuses on the implementation. We're checking that it's exactly 21 characters that the implementation has been coded as. This is a really brittle test, secondly. And thirdly, it tempts you to write a test for every different scenario. So it tempts you to start doing things like boundary testing and doing things that are out of the scope and are going to make the Pact tests burdensome and slow and a drag on the provider, because it doesn't leave the provider free to change things that don't really concern the consumer. So here's a much better example. We're still actually kind of making the same request, but this time our focus is different. We're just using this as a particular example of creating a user with invalid data. So we're just doing one example, and we've picked an example that's likely to not change very often by having a really, really long username. And we're expecting the HTTP response. But this time in our error, we're not expecting an exact error message. We're just saying it should be a string. So this leaves the provider free to change the text of the error message, but it makes sure that the shape of the document is as we expect it, because the most likely use that the consumer is going to have for this error is it's going to parse it and it's going to display it on a screen somewhere. So we're still safe to parse this response and display it in a screen because we know the shape of the document. We don't really need to know exactly what the error text is. Much more maintainable. All right, one of the other traps that you don't want to fall in is adding an assertion for a business rule just because you know it to be true. So, for example, I was out at a client recently, and they were thinking about the matches they would put into their particular contract, and they were like, okay, so all the plans for Victoria have to start with an 8. So I'm going to put a regular expression on this ID to make sure it starts with an 8. So I pushed them a little bit further, and I was like, well, is anything in the consumer code actually going to break if it got a plan ID for Victoria that didn't start with an 8? And the answer was no. There was actually nothing that depended on the format of that ID. This was just a business rule that they knew to be true, and they were putting into the Pact because they knew it, not because it actually affected the consumer code. This is something to be quite careful about. As soon as you start putting in either an exact match or a regular expression, stop and take a step back and ask yourself, am I putting this in assertion just because I know that it's true, or am I putting this assertion in because something will break in the consumer if this rule is broken? And if it's just because you know it's to be true, don't put an assertion in for it. Let it be, let the value be whatever it wants to be. This makes the test much more maintainable because it means the provider is free to change the business rules in the way that they need to without affecting the consumer tests unnecessarily. Okay, so good contract tests aim to expose bugs in the consumer code, misunderstandings from the consumer about the endpoints or the payload, and preventing breaking changes by the provider. We're not actually trying to expose bugs in the provider. That's the job of the provider's own tests. It might come up unintentionally as part of it, but that's not actually one of their aims. Okay, some other tips. Remember how I was saying I'd renamed those provider states? It's because I'm actually really picky about the way the provider states are named. I want when those provider states and the descriptions, when they get sent to the Pact broker and they get turned into a sentence, I want that sentence to read really nicely, because this becomes really good documentation for all the other teams to look at and understand these API and the interaction. So I like to phrase my descriptions and provider states so that I can read it as a sentence, like, given an alligator named Mary exists, that would be the provider state. Upon receiving a request to retrieve an alligator by name, that would be the description. The provider will respond with, and then example document. It's always nice to use the BDD style notation. So you want to try and describe not so much the details of the HTTP request, but the business intent and the business actions where possible, because that makes for much more helpful documentation. So I was trying to think of a really good example. It's really hard to think of on the spot. You might say a request to activate a user rather than a request to set the active field to true. You're trying to think of what the business action is rather than the field level details. We only want to use deterministic data. Where possible, try and avoid using random data in your pacts. I'll explain more about this later. Golly, we only have 10 more minutes. We might have to do the provider stuff another day. You can reuse the provider states where it makes sense, so that the provider doesn't have to do as many, but be a little bit careful so that you don't end up in a situation where you've got the same provider state and you've actually got conflicting data. That's not going to help them. And obviously, what we covered before, make your expectations as loose as possible.